Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2022, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Two pupils are given data that shows the estimated number of computer tablet users worldwide from 2014 to 2018. Lee creates this pie chart to show the data. Write down 2 reasons why Lee's pie chart is not suitable to represent the data. Well, I just think a pie chart is a bad choice for this particular type of data. And the reason for that is pie charts only show proportion, they don't show the values. And here you're actually interested in the values of the computer tablet users and how they're increasing over time. And that doesn't come across very clearly in the pie chart. So I'm going to write down pie charts show proportion, not values. So can't see actual numbers of users. And the second thing is they've kind of drawn it 3D tilted view, haven't they? Okay, and then that makes it even harder to compare. I mean, exactly how big is this angle compared to this one? It's really hard to see, or this one over here. So I'm going to say the 3D tilted style makes it harder to compare sector sizes. Okay, you could also comment, I suppose, on the colours. They're very samey, aren't they? It's really difficult to work out what's what. Part B, Amaya creates this line graph to show the same data. Work out the percentage increase in the number of computer tablet users from 2014 to 2018. Okay, so this one is a little bit more useful, isn't it? I can actually see the numbers of things here. So I want to work out the percentage increase from 2014 to 2018. So what was it in 2014? So in 2014 we had, what, 0.8 billion users. Okay. And then in 2018, we had, what's that on the scale, 1.4 billion users. And we want to do a percentage change here. Now I tend to use this triangle, final original multiply, stick your thumb on it, to do these sorts of questions. So I draw the triangle, then I work out which one of the 3 things I've been given, final, original, or multiplier. Okay, so final is the final price or value after the percentage change has been given. Original is the one before it, and multiplier is the percentage change written as a decimal. Okay, So let's think about final first off. Which one of these values happened first? Was it 2014 first and then 2018, or the other way around? I think you can see that 2018 is the final, and then 2014 must be the original value then, isn't it? So it was originally 0.8 billion, and then the percentage change happened and it became 1.4 billion. Okay, because they're both in billions, I'm just going to leave them as 0.8 and 1.4, because I'm going to divide them one by the other anyway, so the billions will cancel each other out. So I'm just going to say that's 0.8, and I'm going to say that's 1.4. And then what we need to then work out is the multiplier. That's the thing we don't know, isn't it? So using the triangle FOM, going to cover up the thing that I want to find, which is the multiplier, and then that tells me that the calculation is final over original. So multiplier equals final divided by original. Okay, so subbing in my values, 1.4 for final, 0.8 for original. Not got a calculator here, so how am I going to do this? Now I want to turn this into a percentage, so I think if I can get the bottom part of the fraction equal to 100, then that would work out nicely, wouldn't it? So how can I turn 0.8 into 100? So I suppose if I times top and bottom by 10, I'll get 14 over 8, which I could then cancel down to, by dividing top and bottom by 2, I can get 7 over 4. I'm looking for a nice thing I can make into 100. And then so 4 then I can times by 25 times by 25 to get 100. Okay, so then that's going to give me 100 as the denominator. What's 7 lots of 25? That's 175, isn't it? Okay, so I've got 175 over 100, so that is 175%. So what is the percentage increase then? Well, you're going to start with 100% on any percentage change question. If I've now got 175%, then it must have been a 75% increase. Okay? Question 2. The scale diagram below shows the position of two castles, J and K. And the scale is given as 1 centimetre represents 2 kilometres. We're told that the bearing of the tower from castle J is 072 degrees, and that the bearing of the tower from castle K is 116 degrees. Use construction to find the distance from castle J to the tower. Give your answer to the nearest 0.1 kilometre. Okay, so bearings are always given clockwise from north, aren't they? So in order to do this, we're going to have to use bearings, draw them on the diagram, and then see where the two lines meet. So first off, we're going to start with this 072 bearing from J. Okay, so what we need to do is need to put our protractor on the north line. So line up 0 with the north line. Sorry for the rather tatty protractor. And then we're going to count round to 72 on the outside scale, because that's the one starting at 0. Just going to leave a little mark there, and then moving the protractor and using my ruler, I'm going to draw a line from J through the mark that I made. Okay, so I know that the tower's going to be somewhere along this line, but I don't know how far. Okay, right, now we're going to move over to castle K and do the same thing. Place the protractor so the 0 line is on the north line, and then count round clockwise from there to 116 and make a mark. Okay, and then again, removing the protractor and using our ruler, we can draw a line through the mark we've made, and we know that the tower is somewhere along that line. So if it's on both those lines, then clearly the tower is going to be here at this point of intersection. Okay, that's the tower there. Okay, right, so what we need to do now is just to measure the distance then from J to the tower in centimetres, and then we can convert that into kilometres. So I'm making that 6.5. It's kind of between 6.5 and 6.4. I'm just going to go for 6.5, I think. Okay, so that's 6.5 centimetres on the paper, and I know that for every 1 centimetre on the paper, it's 2 kilometres. So if I just double that up, then I'm going to get 6.5 centimetres is equal to 13 kilometres. Okay, Job done. Question 3. Dinosaurs first appeared on Earth 2.4 times 10 to the 8 years ago. And then dinosaurs became extinct on Earth 7 times 10 to the 7 years ago. Explain why it is appropriate to use standard form for these numbers. Well, it's appropriate because the numbers are very large, aren't they? And you've got lots of zeros on the end. Okay? So I'm going to say numbers are large. With lots of zeros. Making them hard to read, I guess. Standard form makes the magnitude of numbers clear. Part B says use the given information to work out how long the dinosaurs existed on Earth. Give your answer in standard form. Right, now to work out how many years they existed, I'm going to have to take one number and take away the other, aren't I? So if I take the 2.4 times 10 to the 8 number and I subtract the 7 times 10 to the 7 number, I should get my answer. Okay. Now the problem here is I've got different parts here and here, so it makes it very difficult to subtract. I need to try and get these the same. And the easiest way to do that is to kind of break a 10 out of that first one. So kind of taking a 10 out of there and timesing it into the 2.4, I'm going to get 24 times 10 to the 7, and I'm going to subtract 7 times 10 to the 7. Okay, so what's that then? So 24 take away 7, that's 17, and it's just going to be 17 times 10 to the 7 again, isn't it? Okay, but that's not quite in standard form. I now need to kind of switch it back again. So if I take a 10 out of this by dividing it by 10 and then kind of adding it back into there, I'm going to get 1.7 times 10 to the 8 as my final answer. Okay, so that's then back into standard form again. So 1.7 times 10 to the 8. Question 4a, complete this statement by writing the missing power in the box. And I've got 784 is equal to 2 to the power something times 7 squared. Okay, so basically what I need to do here is to rewrite 784 as a product of its prime factors. Okay, so if I were to do that, if I was to take 284 and think of two numbers that multiply together to give it, I could take 2 out, then half of 784, what's that? 350 and 42, that's 392. It's half of 784. 392 has got a 2 in it, so let's take another 2 out. So that's going to give me half of 392. That's 150 and 46. So that's 196. These are horrible numbers to half. And then do that again there. I can half 196. I can take another 2 out. And then half of 196 is 98. And then that breaks down into 2 and 49, and then the 49 gives me the 2 7s. Okay, so then how many 2s have I got then? My 2 7s, look, that's what's there. And then I've got 1, 2, 3, 4 2s. So that's 2 to the power 4 times 7 squared, and that's going to give me 784 again. Okay. Part B says use your answer to part A to find the value of the root of 784. Okay, well, the root of 784 then is going to be the same thing as the root of 2 to the power 4 times 7 squared, because I know that 784 is 2 to the power 4 times 7 squared. Now roots you can break up. If you've got two things multiplied together under a root, you can break it off into two separate roots like that. 7 squared is pretty easy. That's going to be 7 when you square root it. Square root of 2 to the power 4. Well, 2 squared times 2 squared is 2 to the 4. So that's going to give me 2 squared. 2 squared times 7. 4 times 7, that's 28 then. So the root of 784 is going to be 28. Question 5. Recipes measure small quantities in teaspoons and tablespoons. 3 teaspoons is equivalent to 1 tablespoon. A cake recipe uses 3/4 of a teaspoon of salt and 1 tablespoon of baking powder. The ratio of salt to baking powder used in the recipe can be written in the form 1 to n. Find the value of n. Okay. Right, so what we've got, 3/4 of a teaspoon of salt to 1 tablespoon of baking powder. So as a ratio then, salt to baking powder. On the left, I'm going to have 3/4 because I've got 3/4 of a teaspoon. So that's the one that goes there. Look. Now on the other side, I've got this 1 tablespoon, but I need to get them in the same units before I can put them into a ratio. So I'm going to use the fact that 3 teaspoons is 1 tablespoon to replace that then with 3 teaspoons. So it's the same size as the one I'm using on the other side of the ratio. So that's going to be 3/4 to 3. Okay. Now I need to change that to a ratio where I've got a 1 here and a number over here. Okay. So how am I going to do that? Well, first off, I'm probably easiest just get rid of the fraction. Times by 4. Okay. So if I times by 4 both sides, I'm going to get 3 because 3/4 times 4 is 3. 3 to 12. Okay. And then to go from 3 to 12 to 1 to something, I'm going to divide by 3 then, aren't I? So divide them the same. That was times 4. This is going to be divided by 3. So 12 divided by 3, and 12 divided by 3 is 4. So what is the value of n? N is equal to 4 then. Question 6. Morgan is playing a computer game. They can score 0, 1, 2 or 3 points on each turn. They record their scores for 100 turns. The table shows the relative frequency of their scores. So we've got the relative frequency of 0, 1 and 2, but 3 is missing and part A says complete the table. Okay. Now, first up, the relative frequencies of all the possible outcomes must be equal to 1. This is kind of the rule of completion. Okay. So therefore, the probability or the relative frequency of getting a 3 is going to be 1 minus the other 3, then isn't it? It's 1 minus 0.08 plus 0.42 plus 0.38. Okay, so what is that then? So 0.08, 0.42 and 0.38. That adds up to 8, 16, 18. Carry 1. 1, 4 and 3 give me 8, so that's 0.88 then, isn't it? So 1 minus 0.88, what's that? That's 0.12. So that's my relative frequency of getting a 3. Okay. Now part B says, Morgan says, I scored more than 160 points in total in my 100 turns. Is Morgan correct? Show how you decide. Okay. Now if he played 100 turns and they were the relative frequencies, then that means if I multiply each one of those by 100, I'll get the number of times that he got those scored. So 0.8 times 100 is 8. 0.42 times 100 is 42. That's going to be 38, and that's going to be 12. Okay, so that's the number of times he got each one of those scores in 100 turns. Okay, so then what's the total of those? And I can kind of multiply them up now then, can't I? I can say total is going to be 0 times 8 plus 1 times 42 plus 2 times 38 plus 3 times 12. Okay, and that gives me 0 plus 42 plus 76 plus 36. What does that come to? Well, 76 and 36 is 112 plus 42 makes 154. Okay, is that right? 36 and 76 is 112. 150, yeah, 154. Okay, so is that more than 160 points? No, it's not. So Morgan is wrong, as 154 is less than 160. Okay. Question 7. A car accelerates at 4.06 meters per second for 10.1 seconds from an initial velocity of 2.93 meters per second. Harper rounds each value to one significant figure. Harper uses the rounded values and the formula s equals ut plus half at squared to estimate the distance travelled in the 10.1 seconds. Harper's answer is 430 meters. Using Harper's method showed that their answer is wrong. Okay, right, so we're going to round each one of these off to one significant figure first. So the car accelerates at 4.06 meters per second. Then that means that our acceleration then to one significant figure is going to be 4. Our value of u is the initial velocity, isn't it? U is the initial velocity. So if I take 2.93, so a was 4, came from there, and then u is this one. So 2.93 rounded off is going to be 3. Then what else have we got? We need t. So t, what's that equal to then? Well, t, that's the time there, isn't it? So the time to one significant figure is going to be 10. Is that everything? Yeah, because I'm going to be I've got u, t, and a, and I need to calculate s. Okay, so I've got my values rounded off. So then my formula is s equals ut plus a half at squared. Okay, so subbing in u is 3. Subbing in t is 10, plus a half, a is 4, and then t is 10, and that is squared. Okay, so applying BIDMAS, got to do the squaring first, but it doesn't affect that first bit, so I'm just going to go ahead and multiply that at the same time. So 10 squared is 100, and then 100 times 4 is 400, and 400 divided by 2 is 200. So that's 30 plus 200. That comes out to be 230 and not 430. So therefore Harper is wrong. Right, so I'm starting with s equals a half at squared. I want to get t by itself. Okay, so multiplying everything through by 2 and dividing by a, I'm going to get 2s over a is equal to t squared. So times 2, that will cancel with that. And then divide by a, Okay, it will cancel there. And it's going to leave me with 2s over a on the left, isn't it? Okay, and then taking roots of both sides, then t is equal to the root of 2s over a. Now normally when you square root you are expected to put plus and minus at the front of it, but you know, with time and these sort of time problems, often the negative solution isn't really a solution, because you can't have, you can't go back in time. Time's always going forward, so the negative solution is not usually a solution. So I'm not going to bother putting it in right here because it isn't always it doesn't always give rise to a valid solution. Okay, but bear in mind normally when you do square root you introduce a plus and a minus version. Question 8. A bag only contains red marbles, blue marbles and yellow marbles. The probability of picking a red marble is 2/5. There are 9 yellow marbles. The probability of picking a blue marble is 3 times as likely as picking a yellow one. Okay. Work out the total number of marbles in the bag. You must show your working. Okay, so if we did that in a table, just going to make a quick table with colour in and the probabilities that we know. Okay, so beep. So colour, probability. So we've got red and we've got yellow. What's the other colour? Blue. Blue. Okay. So we know, what do we know? We know the probability of picking red is 2/5, and we know that the probability of picking a blue one is 3 times as likely as picking a yellow one. So if we said let the probability of picking a yellow one be x, then the probability of picking a blue one would be 3 times as much. It would be 3x, wouldn't it? Okay. Now with probability, all of those need to add up to 1, don't they? So my 2/5 plus my x plus my 3x needs to be equal to 1 because of the law of completion. Okay, so x plus 3x is 4x, and if I take 2/5 away from both sides, I'm going to get 4x is equal to 3/5 on the other side. 1 minus 2/5 is 3/5. Dividing both sides by 4, I'm going to end up with x equals 3/20. Okay, so what does that mean? That means yellow, probability of getting a yellow one is going to be 3 out of 20. So that's 3 out of 20, and that's 9 out of 20. Okay, right, and then so work out the total number of marbles in the bag then. Then if like the total number of marbles was t, then I guess then if there are 9 yellow marbles and 3/20ths of the marbles are yellow, then 3/20ths of the total is equal to 9 then, isn't it? So if 3/20ths of the total is equal to 9, then the total number of marbles is going to be, so cross multiplying, if I move the 20 up there and the 9 down, or the 3 down here, I can rearrange that and say t then is 9 times 20 over 3. So cancel the 3 into the 9 gives me 3. 3 times 20, that's 60 then. So altogether then we had 60 marbles to start with. So 60 marbles. That's the total. Question 9. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimeters from the corner A. We're told that the scale of 1 centimeter represents 20 centimeters. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimeters of corner A, and 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from 2 lines is the angle bisector of those 2 lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those 2 lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of if the ball lies closer to A than to B. So the points that are equidistant from 2 given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points, and I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in 2 places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those 2 arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier, if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'd be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And that one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on. Question 10a. Enlarge triangle A with a scale factor of 1.5 and center of enlargement minus 8, 0. Okay, right, so let's first plot the center of enlargement, minus 8, 0. That's going to be down here then, isn't it? It's on the axis here. So that's my center. Let's just mark it. Center of enlargement. Right, then what we do with a scale factor of 1.5 then is we take each of the distances of each of the 3 corners and we multiply it by our scale factor, and then our image point is going to be that much further away. So, right, now, so if you have a look at this corner down here, okay, at minus 2 zeros, can you see that that is 1, 2, 3, 4, 5, 6 jumps to the right of the center of enlargement? So if I take 6 and I multiply it by 1.5, 6 times 1.5 is 9. So that means my image point is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 points away from the center of enlargement. It's going to be there at 1, 0. Okay, just get rid of that. So that's my first point down there. Okay, now my next corner up here. Now that one is, how many units away is it? So it is like 1, 2, 3, 4, 5, 6 along, and 1, 2, 3, 4 up. So 6 along and 4 up times by 1.5. So rather than having 6 along and 4 up, 6 times 1.4 is 9. So I'm going to go 9 along. 1, 2, 3, 4, 5, 6, 7, 8, 9. And rather than going 4 up, I'm going to do 4 times 1.5. That'd be 6 up. 1, 2, 3, 4, 5, 6. So my point is going to be here. So that's the image point of the green dot. Okay. Then finally, let's make this one blue. So where's the blue dot going to go? So the blue dot is 1, 2, 3, 4, 5, 6, 7, 8 units away, and 1, 2, 3, 4 units up. So 8 along, 4 up. Times that by 1.5. 8 times 1.5 is 12, and 4 times 1.5 is 6. So rather than going 8 along and 4 up, I'm going to go 12 along and 6 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 along and 6 up. 1, 2, 3, 4, 5, 6. So my next point, and my last remaining point, is there. Okay? Okay, into a nice triangle. And then that is going to be my image, which I'm going to label A dash, the image of A. Okay? So yeah, that's it. You can just double check, each side should be like 1.5 times bigger than the original. I can see that top line is 2 and that one's 3, so it does look right to me. Part B says triangle A and triangle B are shown on the coordinate grid below. Yes, they are. Triangle A is mapped onto triangle B using a combination of 2 transformations. A transformation T followed by a reflection in the x-axis. Describe fully the transformation T. Okay. Right, so now I know that what the second step is. That is a reflection in the x-axis. So A is, something happens to A, and then something happens to that thing, T, and then it ends up at B after reflection in the x-axis. Okay, so if we go back to the mid stage then and reflect B back to where it was before it was reflected, then this point here is 2 units away from the mirror line, so its image point is also going to be 2 units away from the mirror line. It's going to be there. And then this corner over here is 2 units away from the mirror line, so its image is going to be 2 units away from the mirror line. It's going to be there. And then finally this point down here, this is 1, 2, 3, 4, 5, 6 units away from the mirror line, so its image is going to be 1, 2, 3, 4, 5, 6 units away from the mirror line as well. So it's going to be up there, isn't it? Okay. If I join those up into a triangle, okay, so then that's going to be my shape after transformation T then, isn't it? So I've got shape A is transformed, I get T, and then T is reflected and I get B. So how can I get T from A? Well, it looks to me like it's either a enlargement with a negative, a scale factor of -1, it could be that, or it could be a rotation. Okay, either of those of 180 degrees, either of those would work. Okay, and in either case, we'd need to work out where the center was. Okay, now with the enlargement, I think centers are usually a little bit easier to find, so I might just do that one. Okay, so if I take a ruler and I join matching points, can you see that one where the right angle is must match with that one there? The more pointy end is the blue one down here, and that means the red one must be there. Okay, so joining object and image together, so the red ones are kind of like there, look, the blue ones are here, and then the green ones are like that. You should see that they all converge on a point. Okay, that is what I am trying to show. So they all kind of meet on a point, and that is going to be the center of your enlargement. Okay, well, in this case it isn't really enlarging, but it's flipping over. Okay, so that there then is the center of enlargement. Yeah, center of enlargement. Now again, I said you could also describe this as a rotation. So if you did it as a rotation, same thing, you'd just say it's rotated around whatever the center of rotation was and the angle. I just think that finding the center of enlargement is usually easier. So then T is an enlargement. Now to describe an enlargement, you need to say the center and the scale factor. So enlargement, center, what's that, 1, 3, that's the coordinate of that center, and then the scale factor is -1, so it stays the same sides but flips over and is on the opposite side of the center of enlargement. Okay, now as I say, you could have had rotation as well. Rotation 180 degrees around 1, 3 would probably have worked as well. Question 11, y is inversely proportional to x squared, y equals 9 when x is 2. Find the value of y when x equals 10. Okay, I like these questions, they're always the same. Really easy to do once you know how to do them. So y is inversely proportional to x squared. So that means y, little fishy symbol, 1 over x squared. Y is proportional to 1 over x squared. Y is inversely proportional to x squared. Okay, so like once we can form the proportion like that, then we can replace that symbol of proportionality, the little fishy symbol, with equals k. So then that becomes y equals k over x squared. Okay, so we've got a partial equation in y and x now. We just need to evaluate what k is, and that's what this pair of values here is there for, is to help us evaluate what that constant of proportionality is. So when y is 9, x is 2, so subbing those two values in, I'm going to get 9 is equal to k over 2 squared. That was the 9, that was the 2 in there. So 2 squared is 4. If I multiply both sides by 4 then, okay, that will cancel with that, and then I'm going to be left with k is equal to 4 lots of 9. 9 times 4 is 36. K is 36. So therefore, equation is y equals 36 over x squared. Okay, now once we've got the equation, we can then go on and find this, then find the value of y when x is 10. Okay, so yeah, the yellow bit gave us this, the green bit is here, that gave us that, and then the blue bit is going to help us find the actual answer. So you don't even worry about find part until you've done all that extra work first. So when x is equal to 10, what's that then? So y is going to be 36 divided by 10 squared. Just kind of subbing that value in then. And then what we're going to get, so that's y equals 36 over 100 then, isn't it? So y equals 36 over 100. Could we leave it as a fraction like that, or you could write it as 0.36. Okay, either way, that's the answer. Question 12. An athlete goes for a training run. The graph shows their speed as they run. So this is a speed time graph. So we've got speed in meters per second along the top and time in seconds along the bottom. Write down the athlete's acceleration between 400 seconds and 1,000 seconds. Okay, so between 400 seconds and 1,000 seconds, we're talking here. So what's the acceleration here? Well, acceleration is equivalent to the gradient of a speed time graph. And between 400 and 1,000, the line is flat. So the gradient is 0, and therefore there's no acceleration. So between 400 and 1,000 seconds, the answer is 0. There's no acceleration. Okay. And it says work out the athlete's average speed in meters per second during the 1,200 seconds. You must show your working. So drawing my distance, speed, time triangle, DST. What do I know? What do I need to find? Okay, well I want to find average speed, don't I? It's this one here. This is the one I want to find. That's the one I don't know. Okay, now I know time. Time is easy squeezy. That's just the amount of time for the whole journey. That is 1,200 seconds, isn't it? Okay. What about distance? Do I know distance? There isn't distance anywhere in the question, but I do know that the distance travelled is equivalent to the area under a speed time graph. Okay, so if I can work out all this area here, then that is going to be the area under the graph. Okay, so what is the area under the graph then? So in here, look, what is all this area? This is the distance. Okay, now the shape of it is a trapezium, isn't it? And I could break it down into a rectangle and two triangles and work them out separately and add them up, but you know, I'm a mathematician. I can use the formula for a trapezium if I want. Okay, so then half a plus b times h then, isn't it? Okay, so a and b are two parallel sides, so that's going to be this length and this length, isn't it? Okay, they're my a's and b's, and then h is going to be the distance between them that way. Okay, so what's a? A is the difference between 400 and 1,000, isn't it? So that's going to be a half of a, which is 1,000, take away 400, that's 600, plus b, which is 1,200, times h. H is from 0 to 4. That's 4 then, isn't it? Times 4. Okay. So I'm going to just divide that 2 into the 4, get rid of it straight away. And that leaves me with 600 plus 1,200, that's 1,800, times 2, that's 3,600. So that's 3,600 meters, I guess. Okay, so then that's my distance then that I can include down here in this calculation. So that's 3,600 then. Okay, so using the DSD triangle, covering up the thing I want to find, that tells me that average speed is going to be distance over time, which in this case then is 3,600 divided by 1,200. Cancel, 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 cancel. 36 divided by 12. That is 3 somethings. 3 what? Meters per second? 3 meters per second. Question 13. The graph of y equals x squared plus 6x minus 2 is shown below. the roots of the equation x squared plus 6x minus 2 equals 0 are at P and Q. Calculate y when x is 1. Okay, so first up, what is the value of y when x is 1? Well, you can find the y coordinate from, if you're given the x coordinate, by just simply subbing in, can't you? So if I've got y is equal to x squared plus 6x minus 2, then when x equals 1, then I'm going to get y is equal to 1 squared plus 6 lots of 1 minus 2. So 1 squared is 1, 6 lots of 1 is 6, take away 2 is 1 plus 6, take away 2, that's 5, isn't it? So y is equal to 5, that's 5. Okay. Without solving the equation, explain why q must lie between 0 and 1. Okay, well we've already just worked out what it is at 1. At 1, we worked out that the value of the equation was 5, which is positive, isn't it? So at 1, we can see the graph is positive. At 0, we can see the graph is negative. So at somewhere between 0 and 1, it stopped being negative and started being positive, which means it crossed the axes, which means the root lies between 0 and 1. Okay, so without solving the equation, y is negative at x equals 0 and positive at x equals 1. Sign change, so must have crossed axes. Okay. Right, so explain why a method of iteration is not the most appropriate way of finding the solution to this equation. Okay, well, iteration is a useful technique, and we usually apply it when the equation we're trying to solve is difficult, or it takes a long time to solve it by methods that we know, or we don't have a method to solve it, so that we apply techniques of iteration to kind of come up with a approximation of the solution. But here we know how to solve this. We've got a quadratic formula, don't we, that we could easily use. Okay, so we wouldn't be using iteration when we've got an available method that is quick and efficient to use. Okay, so we're not going to use iteration because we have better, quicker, and more efficient methods to solve, i.e. quadratic formula. You can just use the quadratic formula to find it. Okay, so yeah, we're not going to use iteration when we've got a formula that we can find it exactly. Part B says the exact value of q is minus 6 plus root 44 over 2. Write minus 6 plus root 44 over 2 in the form a plus root b. Okay. So at the moment I've got like a fraction of 9 with 2 parts on the top. Now I can break that into 2 separate fractions. I can say that's the same thing as minus 6 over 2 plus root 44 over 2. Okay, so you can see, you can combine that. Going back the other way, we would put that over a common denominator, wouldn't we? So it's quite possible to break it up like that. Minus 6 divided by 2, well, that's just minus 3. Now, how can we kind of resolve this? Well, if I say that root 44 divided by 2 is the same thing as root 44 divided by the root of 4, because the root of 4 is 2, then I can take that second part then and write it as a single root 44 over 4 like that, and then I can divide the 4 into the 44, and I'm going to get minus 3 plus root 11. Okay, so that's equal to minus 3 plus root 11. Minus 3 plus root 11. Question 14. In a survey about music, some students were asked whether they like pop and whether they like rap. The Venn diagram shows some of the results. X students liked both types of music. The ratio of the number of students who liked pop to the number who liked rap was 5 to 2. Work out the total number of students in the survey. Ooh, that's interesting. So I guess the total number who like pop, the number who like pop that is going to be the 28 on the left hand side plus the x part in the middle, and the number who like wrap, that is going to be the x in the middle plus the 1, isn't it? Okay, now we're told that the number who like pop to the number who like wrap is in the ratio of 5 to 2. Okay, so can we turn that into an equation? So if the ratio of what they like is, if they're in the ratio of 5 to 2, that means if I took the ratio who liked wrap and I timesed it by 5 and I divided it by 2, I would get the number of people who liked pop. Okay, does that make sense? So then just cross multiplying that 2 over here, I'm going to get 2 lots of 28 plus x is equal to 5x plus 1. Multiplying out the brackets, so that's equals. Multiplying out the brackets, I'm going to get 56 plus 2x equals 5x plus 5. Taking 2x away from both sides and subtracting 5, I'm going to end up with 3x equals 51. And therefore x is equal to, what's 51 divided by 3? That's going to be 17, isn't it? Okay, so that tells me there must be 17 people in the middle here then. Okay, so then what's the total number of people in the survey? So the total is going to be each of those regions of the Venn diagram added together. So it's going to be the 28 in the left plus the 17 in the middle plus the 1 in the right plus the 13 outside the circle. What's that add up to? 28, 38, 45, 46, 56, 59. So there are 59 people in the survey. Part B, one of the students is selected at random. Find the probability that the student does not like wrap given that they like pop. Okay, right, now this is a conditional probability question. We are given that they like pop, which means we are selecting from this area only and not the whole Venn diagram. Okay, so given that they like pop, what is the probability that they don't like wrap? Okay, well, the people who don't like wrap are those people in there, aren't they? The people who like pop and don't like wrap. Okay, so the probability then they don't like wrap given that they like pop is going to be the 28 that don't like wrap in that area divided by the 28 plus 17 that they are in total. So that's 28 over 28 plus 17, that's 38, 45, isn't it? So that's going to give me a probability of 28 over 45. Question 15. ABC is an equilateral triangle of side length 2 centimeters. M is the midpoint of AC. Using the diagram, show that tan 30 degrees is 1 over root 3. Okay. Well, normally when I introduce exact trigonometric angles with my students, I would show them this anyway, so hopefully it's something you've seen before. So if M is the midpoint and it's cut this line in half, then that one is going to be 1 and that's going to be 1, isn't it, from there to there. Okay, can you see that? Okay, so we know that length is 1. We already know the hypotenuse. So using Pythagoras theorem, we should be able to find the line BM, shouldn't we? Okay, so using c squared equals a squared plus b squared, but we know c squared here, isn't it? It's the shorter side that we want to find. So then a squared equals c squared minus b squared, isn't it? So in this case, the longest side is 2, so 2 squared, and the shorter side then we just said was 1, so 2 squared minus 1 squared. That's 4 subtract 1, that's 3, isn't it? So a squared is equal to 3, so a is going to be the root of 3. Okay, so that means that length there is root 3. Okay, and so using trigonometry, tan theta is equal to the opposite over the adjacent. So in this case, theta is, we want this angle up here then, that's the 30 degree angle, isn't it? Because if that's 60, then that's 60 across all the way there, so halving it is going to give me 30 and 30, isn't it? So I want my theta is going to be up here, tan 30, so tan 30 is equal to the opposite. So what's opposite the angle? It's 1. So this is going to be my opposite over here. This is the op. And then the adjacent is going to be this side here, isn't it? And this is the hypotenuse of this triangle. Should really have said I'm using this triangle here. Okay, with the angle at the top. So tan 30 is equal to 1 over the adjacent, which we just said is root 3. It's the value we found using trigonometry. So there we go. Tan 30 is 1 over root 3. Question 16. Work out 0.6 reoccurring times 0.54 reoccurring. Given your answer as a fraction in its simplest form, you must show your working. Okay. Right, so I'm not going to attempt to multiply two reoccurring decimals together. I'm going to try and first convert each one of them into a fraction and then multiply those together, because I find fraction multiplication a whole lot easier. So that's what I'm going to do. Right, so let's take this one first, 0.6 reoccurring. Now there's a trick for rewriting these as a fraction. You probably know it already. So I say let x be the recurring decimal that I've got. I've got 0.66666, etc. And then I work out what 10 times it is. So what would 10x be? That would shift every digit along to the left one, isn't it? That would be 6.6666666. And then if I subtract one from the other, then that's going to cancel, and I'm just left with 6 minus 0, which is 6. Okay, so 10x minus x is 9x, 6 minus 0 is 6. So 9x equals 6, which means x equals 6/9 or 2/3. You probably knew that already. Okay, but I've just done it anyway. Let's do the same thing with 0.54. We'll start off with x, and that's 0.54. There's a dot on the 5 and the 4, which means the 54 kind of keeps recurring like that. So this case, you don't want to times it by 10 because your digits won't match up. You want to times it by 100. So 100x would be 54.54545454. So instead, if you times it by 10, you'd have 5.454545, and then it wouldn't cancel. So I have to times it through by 100 in this case. And then if we do a subtraction this side, you can see on the left hand side I'm going to get 99x. And what about the right hand side? And again, all these digits this side are going to cancel with these, and it's just going to leave me with 54. Okay, so that's 99x is equal to 54. Give me x equals 54 over 99. Does that cancel down? And they're both divisible by 3, aren't they? 3's into 99 go 33. 3's into 54. What's that? That's 18. So 18 over 33. Still divisible by 3. We get another 3 out of those. So what's that? That's 6 over 11. Yeah, 6 over 11. I could have divided both by 9 to start with, couldn't I? 6/11. Okay, so that's a little bit more easy to manage. Okay, so I've got one of my fractions is 2/3, and one of my fractions is 6/11. So if I then multiply these two things together, if I take 0.6 recurring and I multiply it by 0.54 recurring like that, that's equivalent to multiplying 2/3 with 6/11, isn't it? Okay, can I cancel anything first? That 3 cancels into the 6, give me 2 and 1. Anything else that can cancel? No, don't think so. So 2 times 2, that's 4 on the top. 1 times 11, it's 11. So the answer is 4/11. 4 over 11. Question 17. Charlie is making some wooden frames. Charlie has a strip of wood which is 1.6 meters long and 2 centimeters wide. Each frame will be made from 4 pieces of wood cut from the strip to form a rectangle as shown below. So the width of each frame is x centimeters. The length of each frame is 2x centimeters. The area enclosed by each frame must be 96 centimeters squared. Work out the maximum number of frames Charlie can make from 1.6 meters length of wood. You must show your working. Okay, this is a nice problem. Right, so what are the dimensions of this shape? It's 2x and x, and it has an internal area of 96 centimeters squared. Okay, that's interesting. So then presumably this distance from here to here then is going to be x minus 2 and 2, isn't it? So x minus 4 in that direction. And then from here to here, that's going to be 2x minus 2, 4 as well, isn't it? So that's going to be 2x minus 4, okay? And then those two things multiply together, so x minus 4 times 2x minus 4, that is going to be equal to the area I've been given then, isn't it, of 96, okay? Now I want to solve this and work out what x is. So I think what I'm going to do is I'm going to multiply it all out first and see if I can reform it into another quadratic that I can solve. Okay, so just doing FOIL on here, first outside, inside, last. I'm going to get 2x squared minus 4x minus 8x plus 16, and that is equal to 96. So collecting like terms together, minus 4x minus 8x is minus 12x plus 16. I'm going to take the 96 over to the other side so it becomes minus 16, take away 96. That is minus 80, isn't it? Okay, and that's all equal to 0. Right, now notice that I've got multiples of 2 everywhere. So before I factorize, I'm just going to simplify this by dividing everything by 2. So I'm going to get x squared minus 6x minus 40 is equal to 0. Okay, that should make factorizing a little bit easier. So I'm going to have x and x here. Factor pairs of 40. Right, what goes into 40? 1 and 40, 2 and 20, 3, nope, 4 and 10, 5, yep, 5 and 6. 5 and 8, sorry, 6 notes, 7 notes. So that's all the factor pairs. Okay, now I'm looking for a factor pair that has a difference of negative 6. Okay, so I'm thinking it must be this pair here then. So if I have like plus 4 minus 10, that's going to give me minus 6 in the middle. So plus 4 minus 10 in there. Now that gives me two solutions for x. X equals minus 4, x equals 10. Okay, now so you might be thinking, is there two solutions to this problem? But no, there's not now, because x minus 4 is a solution to the particular equation I was looking at, but it's not a solution to the problem, because here x is a length, and unless we're living in some sort of alternate reality, we can't have a negative length. So that one is not a solution. Not a solution. Okay? Can't have a negative length here. So that means that x equals 10 is the length. So that means that this longer piece of wood is going to be 2 lots of 10. It's going to be 20, isn't it? So I need one piece of wood which is 20. Well, I actually need 2 of those because it's the top and the bottom of the frame. And what's the shorter one then? The shorter one is going to be x10, take away 2, take away 2. So that's going to be a 6 centimeter frame then, isn't it? And I need 2 of those. Okay, so total required is going to be 20 times 2 plus 6 times 2, which is 40 and 12 is 52 centimeters. Okay, now how much wood have I got? I've got 1.6 meters, which in centimeters, that's 160 centimeters, isn't it? Okay, so how many frames can I make? Number of frames is going to be the 160 centimeters I've got divided by the length 52. How many times does 52 go into 160? Well, it's roughly 3, isn't it? It's 3 with a bit left over. 3 remainder. 52 times 3 is 156. So it's going to be another 4 centimeters wasted, isn't it? But it roughly goes in 3 times, okay, with a little bit to spare. So we can make 3 frames from that length of wood. Okay, 3. Question 18. The diagram shows a shaded shape made by removing sector OAB from sector OCD. Both sectors have an angle of 60 degrees. The radius OA of the smaller sector is r centimeters. The ratio of the radius of OA to OC is 2 to 3. Work out in terms of pi and r the total length of the arc AB and arc AC. give your answer in its simplest form. You must show you're working. So what do we need to do? We need to work out the length of this arc and the length of this arc, and then we need to add them together. Okay, that's what we need to find. So we need to find arc AB plus arc AC. They're the two things we need to find. Now, how are we going to do those? What have we actually been given? We've been given the ratio of the radius of OA to OC. So that is 2 for every 3 we've got for OC. So O to C would be 3, wouldn't it? Okay. Now, this is on one hand, it's a similar shapes problem, isn't it? Because if the lengths of the radius in the ratio of 2 to 3, then so will the arc lengths. The arc lengths are going to be in the same ratio, aren't they? Because these are two similar arcs. Okay, you could consider the smaller sector and the larger sector to be similar shapes, and so because the ratio of one of their lengths is in the ratio of 2 to 3, then that means that the ratio of all of their lengths are in the ratio of 2 to 3, which means that for every 2 units we're going to have on the yellow one, we're going to have 3 units on the green one. Okay, so we know that, so that's given. Okay, now what do we need to find? So normally the length of an arc length is going to be 2 pi r, the circumference of a circle, the whole circle, and then whatever fraction that we've got of it. So here we've got 360th, haven't we? Because we've got 60-degree angle in the center. Okay, so it's going to be 60 over 360 of 2 pi r. Now 60 over 360, 6 over 36, that's 1/6, isn't it? So that's 2 pi r over 6, or pi r over 3 then. So that simplifies down to pi r over 3. Okay, so we're saying that arc length there, so then AB is going to be pi r over 3. Okay, so now I know already, we've already discussed then that if they're similar, then AB to CD are going to be in the same ratio as the radius, so they're going to be in the ratio of 2 to 3. Okay, now I now know that AB is pi r over 3. So how can I work out the other ratio on this side? Okay, well, I'm going to use the unitary method, which I do with ratios. If I want to go from 2 to that, then I'm going to go via 1. So to get there, I'm going to divide by 2 and then times by pi r over 3 then, aren't I? Okay, so doing the same thing on this side, 3 divided by 2, that's going to give me 3 over 2. Okay, and then taking 3 over 2 and multiplying it by pi r over 3, that's going to give me 3 over 2 times pi r over 3 then, isn't it? Okay, now I can see already that 3 and that 3 cancel, and that's just going to give me then pi r over 2 then, isn't it? Okay, so then CD then is going to be pi r over 2, just using simple ratios. Okay, so once I know that CD is pi r over 2, then I'm going to work out what arc length AB plus arc length CD is. So what is arc AB plus arc CD? Well, arc AB was there. Arc AB was pi r over 3, and arc CD, that's that one down there, arc CD was pi r over 2. Okay, so then we need to add these together. So we need to make a common denominator. 3 and 2 have a common denominator of 6. So I'm going to need 2 lots of pi r plus 3 lots of pi r on the top then, isn't it? And that's going to give me 5 lots of pi r over 6. Okay, a third of something plus a half of something is 5/6 of that something. So that's my answer. 5 pi r over 6. Question 19. The graph below shows a circle with center origin and equation x squared plus y squared equals 169. Show that the point minus 12, 5 lies on the circumference of the circle. Okay. Right, now we should know immediately that the radius of circle is what? What's the radius of this circle? Radius of a circle. Well, we can see it here from either from the axes there. Look, it goes from 0 to 13. It's got a radius of 13. Or we know that x squared plus y squared equals r squared. So that is going to be the square of the radius. Square root 169 gives you the same answer of 13. That's a radius of 13 centimeters. Okay? So what we're going to do to work out if a point lies on a circumference is we're going to find the length of the radius from the center to that point. I'm going to, well, the length of the line from the center to that point to see if it's equal to 13, because if it is, it must lie on the radius. Okay, so let's say minus 12, 5. Now you can see it's going to be somewhere over here. Okay, now it could be that it's lying on the circle, it could be that it's slightly inside the circle, it could be that it's slightly outside the circle. So what we're doing is we're taking this distance, we're going to find this distance here. So if it's exactly 13, it lies on the center, on the circle, on the circumference. If it's more than 13, it lies outside the circle, and if it's less than 13, it lies inside the circle. Okay, so we want to find the line of a line segment going from point 0, 0 up to point minus 12, 5. Yeah. Okay, so I'm going to call this one x1, y1, and I'm going to call this one x2, y2. Now there's a formula for length of a line segment. Length of line segment O, what's the point called? Call it P, OP, and that's given by the root of x1 plus x2 all squared plus y1 plus y2 all squared. Now I would just remember this formula. Okay, it's derived from Pythagoras theorem. It's a very handy one just to be able to remember and write down. Okay, so x1 is 0, so that's going to be 0 plus x2, which is minus 12 all squared, plus y1, which is 0, plus y2, which is 5 all squared. Okay, so that's just minus 12 squared plus 5 squared, isn't it? All square rooted. Well, minus 12 squared squared is 144. It's still positive. And 5 squared squared is 25. Add them together, I think you get 169, don't you? Okay. And so therefore root 69, 169 is 13. Okay. And then because this length here then matches the radius, then it must be that this line takes you exactly to the edge and no further. Okay, so then we can therefore say then that therefore point does lie on circumference. Okay, sometimes the questions say prove that it lies inside the circle, in which case you'd have to show it's less than the radius. Sometimes it says prove that the point lies outside the circle. Sometimes it says prove that the point lies on the circumference. They're all variants of the same question. You just find the length of the line and you compare it to the radius. Now part B says find the equation of the tangent to the circle at the point minus 12, 5. Give your answer in the form y equals mx plus c. Okay, so now we know that minus 12, 5 does lie on the circle. Now I don't know why I plotted it down in the third quadrant last time. Minus 12, 5 is actually up here, isn't it? I don't know what I was thinking about earlier. So that is the point P actually. It's up there, not down there. It didn't really affect my working from earlier. Okay, so I'm not going to go back and change it now. But minus P is actually up there, minus 12, 5. And it's useful to get this one right. Okay, so a tangent drawn at P is going to be a straight line that just touches the circle at that point. Okay, so I'm going to draw that on. Now, this is a shape and space question. And I really think that you need to start thinking in terms of shape and space. So get into the habit of drawing diagrams, adding things to your diagram as you go along. It will bring clarity to your thinking. Okay, so so I've drawn on the tangent that passes through the circle at P, which is at 12, 5. And I've also added on the radius that goes from the origin to the point P. Now, if you know anything about circle theorems, you should know that a tangent and a radius drawn at the point of contact are always at right angles to each other. Now, I can use that amazing fact here, because if I can work out the gradient of the radius, then I've got a trick then to switch that over into the gradient of a perpendicular line, and therefore I can find the gradient of the tangent. Once I've got the gradient of the tangent, I know it passes through that point, minus 12, 5. I can go on to find the equation of the line. Okay, so that's my plan. Let's put into action. So step 1, find gradient of the radius. So gradient of radius, which is OP. Okay, then M1, let's call it M1. So remember, origin is 0, 0, which I'm going to call x1, y1, and P is minus 12, 5, which I'm going to call x2, y2. Then the formula for finding gradient is change in y, y2 minus y1, over change in x, x2 minus x1. Again, I reckon you should just memorize this formula. It's super handy in these sorts of questions. So subbing in what I know, y2 is 5, 5 minus 0 divided by x2 minus 12 minus 0. That comes out to be negative 5/12, doesn't it? Okay, so that's my gradient of my radius. Okay, now the gradient of the tangent is perpendicular to the gradient of the radius. So my M2 is going to be the negative reciprocal of M1, isn't it? Okay, so I'm going to take my fraction of minus 5 over 12. I'm going to flip it over, and I'm going to change the sign. So the gradient of my tangent is going to be 12/5. Okay, so I'm going to let equation be of form. Now, equation of a straight line is the form y equals mx plus c, but I've already found m is 12 over 5. So it's going to be the form y equals 12/5 of x plus c, where c is the y-intercept. Okay. Now I just really need then to find c to finish off this equation, and I can use this point that it passes through, minus 12, 5, to help me. So I can say it passes through minus 12, 5, and I can sub those two values in for x and y. So y is 5, 5 equals 12/5 of x, which is minus 12, plus c, the y-intercept. Okay, so what's that then? So that's going to give me 12 times minus 12, that's minus 144 over 5. So 5 equals minus 144 over 5 plus c. So taking that the other side, I'm going to get c equals 5 plus 144 over 5. Okay, what's that then? Well, 5 is 25 over 5, and then 144 over 5 plus 25 over 5, that's 169 over 5. So c is 169 over 5. Okay, so completing this equation, I've got, therefore, equation is y is equal to 12 over 5x plus 169 over 5. Okay, that's my solution. And I believe that's the end of the paper. Huzzah! You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.